Without use of the square root or cube root function, determine if each of the following numbers are perfect squares and/or perfect cubes. We first have to prime factorize these numbers. Once we have the prime factors, we try to arrange them into groups of 2 or 3. If we can arrange them into groups of 2, then we have a perfect square. If we can arrange them in groups of 3, we have a perfect cube. For A, 6,084, we can first break that up to 4 times 1,521. The 4 breaks up to 2 times 2, and we break up 1,521 to 3 times 507. We can then further break down 507 to 3 times 169, and then 169 is 13 times 13. Note that we can break up these prime factors as 2 times 2, as we have 2 2's. We have 2 3's, 3 times 3, and 2 13's, 13 times 13. Since we've arranged these in pairs, 6,084 is a perfect square. For B, 13,824, we can first break that up to 24 times 576. The 24 becomes 4 times 6. 576 becomes 4 times 144. We can break 4 down to 2 times 2. 6 becomes 2 times 3. The 4, again, 2 times 2. And 144 becomes 12 times 12. We can further break down the 12 to 3 times 4 for both of them. And then both of the 4's become 2 times 2. We can then write 13,824 as 2 times 2 times 2. We have 3 2's here. We have another group of 3 2's, and then yet another group of 3 2's. Finally, we have a group of 3 3's. Because these are all arranged in 3's, this number, 13,824, is a perfect cube. For C, 3,528. We can first write it as 24 times 147. 24 breaks up to 4 times 6, and 147 is 49 times 3. We further break down 4 to 2 times 2, 6 to 2 times 3, and 49 to 7 times 7. Right away we note that there is no way we can arrange these numbers so that we have groups of 2 or groups of 3. This is then neither a perfect square nor a perfect cube. For D, 46,654. We first can break that up to 64 times 729. 64 is 8 times 8, and 729 is 27 times 27. We further break down each 8 to 2 times 2 times 2, and each 27 to 3 times 3 times 3. We can then write 46,654 as 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3 times 3 times 3. Notice we have arranged everything into groups of 2. We can also write it 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3 times 3 times 3. This time we've arranged all of the prime factors into groups of 3. We can then say that 46,654 is both a perfect square and a perfect cube.